So, what is wedge product? Actually, this question was asked by one of my BSc student. It is topic of BSc first year, and you can see this is syllabus, and here wedge product is mentioned. So, one of BSc student informed me that there is nothing much details about the wedge product in books that are available. So I don't know writers of these books, but definitely when I checked, so there is nothing given about wedge product in this book. So so as you can see that they have just given about vector algebra, dot product, cross product, but they have not given anything about the wedge product. So to be confirmed, I checked another book, and let's see. So they seems to have given something on this. See, they have summarized wedge product in just 4 or 5 lines, here and here. It is kind of, you just read its definition. Can a BSc level student understand it? Definitely not. They should have elaborated it in much details, and also they should have given some examples about this. So actually these people will write only those things they know. They have nothing to do about syllabus or nothing to do about the outcomes. They are doing just business. So they write in book only those things which they know. So on the basis of rank, suppose on the basis of rank we divide physical quantities in few parts, like we call 0D objects. They are scalars. So you definitely have heard many times about the scalar is zero rank tensor, so something like that. And you also have heard about 1D objects that are called vectors. So nothing new here. So there can be also 2D objects which are called bivectors. Okay, so they are combination of two vectors in some manner. So as you know, vectors live in abstract space called vector space. Like there is a place where all vectors live, and this place is called vector space. And similarly, there is a space where all bivector lives is called exterior spaces. Okay, so bivector is a member from exterior space, and it is made up of two vector. The process of making bivector from two different vectors is called wedge product. Okay, the process of making bivector from vectors or two vectors is called wedge product. Is called wedge product. Okay, so you know bivectors are area plus orientation. Like if we have vector, then definitely we have its magnitude and its direction. So if we have bivector, definitely we will look for two things. First one is area, and second one is orientation. So two things are important. The magnitude of a bivector will be its area, and its direction, something maybe its orientation. So this can be representation of a bivector. So suppose we have vector A and then vector B. So combining these two vectors, we can make a bivector like this, and it can be expressed in some specific order, like vector A wedge vector B. So this is called a bivector, and this product is called wedge product. Okay, so if someone asked about this magnitude, so if you want to take magnitude of vector A wedge B. So this will be area made up by parallelogram of vector A and vector B. Okay, it is something like cross product. So, and its orientation will be from vector A to vector B side. So this will be parallelogram, this is vector A and this is vector B, so orientation will be like this. Okay, suppose we have a wedge vector like this. So this will be negative of first, this is A, this is B, so this will be A wedge B and this will be minus B wedge A. Okay, this is A wedge B and this is minus B wedge A. So these are bivectors, and this kind of product is called wedge product. As we write unit vectors in vector space I cap, j cap, k cap, so like this we can write unit y vector in exterior space like I cap wedge j cap wedge k cap and k cap wedge I cap. So I cap j cap means the area of parallelogram made up by I cap and j cap, and orientation will be from I to j side. Similarly, this area of parallelogram made up of j vector and k vector, and here area of parallelogram made up by k vector and I vector. So these are called unit y vector of this vector space. Suppose we are given some vectors and we want to find out its y vector, resultant y vector. Suppose you are given u is equal to a I cap plus b j cap and v is equal to c I cap plus d j cap. So if you want vector u wedge vector v, then definitely you have to follow some rules. So first thing, wedge product is distributive, so these brackets can be distributed like a I cap wedge c I cap plus d j cap plus b j cap wedge c I cap plus d j cap. Okay, now you can distribute this vector on this bracket, so this can be written as a I cap wedge c I cap, okay, plus a I cap plus d j cap plus b j cap plus c I cap plus b j cap wedge d, this is wedge actually, I'm sorry, d j cap. So you can take constant term out. Okay, so here we will write a c and wedge bracket I wedge I plus a d bracket I wedge j plus b c bracket j wedge I plus b d bracket j wedge j. Okay, so we have taken this coefficient term outside, and in bracket we have all bivectors. So I wedge I means the area of parallelogram made up by vector I and I. So these they are these same vectors, so the area of parallelogram will be 0, so this term will be 0, and also here we have j wedge j, so the area of parallelogram will also be 0. So we are left with two terms, I wedge j and j wedge I. So we know that I wedge j is negative of j wedge I, so we can write it a d I wedge j minus b c I wedge j. So we can take this term common, so the result will be a d minus b c I wedge j. So these are some basic rules by which we can take product in exterior algebra, or we can create bivector. So if